Bismillahirrahmanirrahim. My name is ABDIRAHMAN, and today we are presenting on how to design an earth dam. So in this group we are only three students, me, myself, MOHAMMAD, HAFIZ and SANIY. So in my part of this presentation is the introduction and design criteria. So our earth dam design project intertwines basic engineering, environmental consideration, and sustainability. A delicate dance between in infrastructure needs and environmental protection. These projects showcase an coexistence between human-made structure and natural forces. Sewage management, slope stability, and environmental effects from a force requires an extreme caution in our evolution voyage. Slope stability and sewage control. Slope stability is not just structural, it is an important component for long-term resilience, considering land contours, geological formation, and gravitational forces. Sewage control becomes an art form, regulating water flow integrally and strengthens the dam against potential vulnerabilities. Environmental responsibilities. Beyond construction, the project devolves into ethics of environmental impact, acknowledging the direct relationship between human action and nature. Although environmental impact assessment serves as our compass, steering towards sustainability and ensuring the dam in both guardian and utility provider. Design criteria. Guiding principles. We have to design standards crafted from geology, hydrological, and environmental factors. Guide the project towards a long-lasting and harmonious integration with a natural environment. The dam's response to water flow, structure integrity, and ecological responsibility are integrated, forming an historic design that maximizes functionality and resiliency. Through the sewage analysis and proactive measures, our goal is to strengthen the dam against the future threats and enhance overall reliability. So that's all for me. Thank you.
Okay, now we're going to do our meteorology and terminology. There is a few things that we need to check first. There is our fresh rock, and then our weather that is slightly, moderately, highly, and completely. And the last one, the soil that we use. And then we're going to check our classification of the rock. That is a 5 thing. That's unaxial compression strength, and then prefigure deformation, and failure characterization, and gross homogeneity, and community in formation. And then this is the type of rock that we have. And then we're going to check the strength of all the type of rock that we have. And you can see this. Okay, next we're going to do our gravity slip dislocation instead. There is a gravity slip dislocation in slip wheel valley, the alluvial, glacial, and landslide deposit on the floor and side of valley. Generally have a location, contribution, and physical properties. They are identified in a field with a relative area. During planning, design and compression of them is reserved as assessment of this deposit can be made without this difficulty, and appropriate measure can be taken for their removal and stabilize. And then it's many steps will valid that we have. There is stream cut or plus yet and relativity relativity in conspiration kind of failure present, especially in highly competent. Okay, now we're going to do the obstruction in stream valley. There is two major consequences of impounding water in natural or intensification reserve. There are a deposit of all much the suspended and traction load transport by the stream, and increase in downward and lateral erosion by clear or desilted water downstream for the obstruction, and then attempted to control the rate of failing of reservation by sediment may include a contraction of dam and reservoir in intercept sediment upstream to the major facility, such as a large of dam for electricity power generation and regional program of for solid stabilization and conservation in upstream drainage basin. Okay, now we can see the topographical and geological condition for the different type of dam. There is concrete dam. There is we have 5. There is a gravity dam, buttress dam, multiple arch dam, thin arch dam, and thin arch dam. There is embarked dam that we have is rock fill dam, hydraulic fill dam, earth dam, and embarked dam, and compressor dam. Okay, this is the hydrological circle that we have to know the step from the upstream to the downstream of the water. Okay, this is analyzed cross section of dam showing various kind of zone of potential sea space and backhaul. That you can see there's a lot of sample that we have, and then this one also the cross section that we have to of a valley at dam and all revision site. Next, we're going to do our foundation content. That is pressure associated with a dam and reservoir, construction of a dam filling of the reservoir behind it create load stress on the floor and side of the valley that did not exist previously. The kind and distribution of imposed stress created by dam on its fundamental depend on the shape of dam and the material used in the construction. And then the pressure extended by earth and what we feel dam resemble in some respect those extended by water in reversion, but pressure distribution is modified by the fact that the material of contraction have some inherent strength and fail only after some this whole stress has been existed. So next is the dead weight load of the constructed dam is distribution over the total area of the foundation and is low by vector normal of the face beneath the dam. The figure that you can see accessible face static and depend only on the weight of the dam and the area of the foundation. Okay, next we're going to see our force action and rigid dam owing the hydrostatic pressure. In calculation of stability of the dam, the top tending to rotate the dam about zero should be added to the tendency of them to be rotate in the same direction about the same point of outlift force related to the seepage beneath the dam. Can you see the picture at the beside? So this is the first dam that you can see, the earth dam. The pressure we going to the downstream, and then this is a cross section of concrete gravity dam. As you can see, the center of the gravity is in the picture. When the reservoir is empty, the weight of the dam decrease vertically down. When the reservoir is full, the combination of hydrostatic pressure in the upstream phase and the weight of the dam produce a force vector incline downstream away from the vertical force vector, and the tendency for the dam not only the displace downstream but also rotate about downstream to the dam because of top. And then this is sample of arch dam. Okay, next is our figure that below show a machine of foundation fail under load of has been wide appeared in analysis of bring strength of soil. This mechanism respond to analysis by application of more theory or of shear failure. We call it a plastic method of analysis of bearing capacity.
Assalamualaikum. So the next is seepage analysis. Seepage under an embankment is much more dangerous than that for a concrete dam, since embankments are usually built on soft material which is liable to be sourced out, and it also vulnerable to influx of water. Whereas a concrete dam is usually built on rock which is not warmed away too rapidly by the scorching action of water, and even the defective dam will not necessarily be endangered by passage of water through it or even under it. So the first one is basic seepage problem. The first point is store water behind dam give rise to three basic seepage problem which can lead to difficulties and in serious case to total failure. The next is piping occur when water pick up soil particles and move them through unprotected exits, developing unseen channel or pipes through a dam or its foundation. And heave or slope failure caused by seepage force, excessive loss of water. And the three basic methods for controlling seepage are use of filter to prevent piping and heave, seepage reduction, and drainage. So the first one is seepage reduction. Basic consideration for seepage reduction is method make use of impermeable cut off from curtain and upstream blanket which consume energy at location within cross section where large water pressure and seepage force has no detrimental effect. The net result of this method is that water pressure and seepage force are reduced in the downstream region. These seepage reducing features are usually combined with properly designed filter and drainage features, since seepage reduction can only be partially effective by itself. And next is drainage method. First is permeable downstream shells. At dam site where there is an abundance of at least two different materials with significantly different permeability, a zone dam may be constructed. In such case, permeable material is placed downstream of less permeable material, often with a transition zone between. For example, in a zone dam which has a thick impermeable core and rests on impermeable foundation, The flow path within the downstream portion of the dam will be low. Thus, seepage has a negligible effect on the stability of the downstream slope, which is the ideal condition in zone dam. So the purpose is a homogeneous dam with a height of more than about 6 meter to 8 meters should have some type of downstream drain. So the purpose of the drain is to reduce the pore water pressure in the downstream portion of the dam, therefore increasing the ability of the downstream slope against sliding. Next is to control any seepage that exists the downstream portion of the dam and prevent erosion of the downstream slope. The effectiveness of the drain is reducing pore pressure depends on its location and extent. However, piping is controlled by ensuring that the grading of the previous material from which the drain is constructed meet the filter requirement for the embankment material. Toe drains. For low dam, a simple toe drain can be used successfully. Toe drains have been installed in some of the oldest homogeneous dams in an effort to prevent softening and erosion of the downstream toe. The cause of the settlement. The first one is bearing capacity failure or instability, including landslide. Second, failure of deflection of the foundation structure. Third is elastic or distortion of the soil or rock. 4. Consolidation, compression of the soil or rock. 5. Shrinkage due to desiccation. 6. Change in density due to shock or vibration. 7. Chemical alteration of constituents, including decay. 8. Underground erosion. 9. Collapse of underground openings such as cave or mines. And last, structural collapse due to weakening of cementation upon saturation. So the dam construction on unconsolidated deposit. Rockfill dam improve membrane. Asphaltic concrete extend to a groove cap on bedrock. Second, cut-off trench extend to bedrock. Third, cut-off trench penetrate improvised layer in unconsolidated valley fill. Cut-off extend to layer of impervious material in unconsolidated valley fill. Rock holes extend through a limestone layer in bedrock below valley fill. Next is a cut-off is provided by sheet filling driver into a impervious layer in the valley fill. And last, flow beneath the dam is reduced by a layer of impervious material placed upstream from the dam. Next is groove. Groove is a liquid, either a uniform chemical substance or an aqueous suspension of solid that is injected into rock or unconsolidated material through specially drilled boreholes to improve bulk physical properties and or to eliminate seepage of groundwater. So there are three basic types for groove, which is number 1 is Portland cement-based slurry, second chemical grouting solution, and third is organic resin including epoxy resin. Portland-based are the most widely used. So the type of grouting in the dam foundation, 3 kinds of grouting program are identified. So the first one is shallow blanket or consolidation grouting of a critical portion. Second, curtain grouting from a gallery or concrete rock cap. Third, of pattern special purpose grouting to improve strength. Some cross-section of dam with rock foundation showing location of drill holes for foundation treatment. As you can see at the picture at the right, they have an alphabet A, B, C, D. So the A is curtain grout hole, the B is blanket grout hole, C special purpose of pattern grout hole, and D is drain holes. And next is the concept and criteria. A gravity dam should be safe against overturning at any horizontal plane within the dam. Second, safe against sliding at any horizontal place within the dam, and so proportion at that the allowable stresses in the both the concrete and the foundation should not be exceeded. Drainage is in the form of curtain of core vertical holes 150 mm or more in diameter at 3 to 5 meters spacing and located 304 meters from the upstream space. A gallery run from one end to the other of the dam above the third water level. Drainage from the hose is lead away via open gutter which measuring wheel installed to record the flow.
So this is our earth fill dam content. This is the type that we have that is homogeneous and thin canal core and inclined core concept. That in the summary that we can have, design of a dam involves consider the following key aspect. The first one is dam criteria, design criteria. Understand the site characteristic like rainfall, soil and econology and set design standard. Dam design use soil mechanic and hydraulic engineering principle to design the structure including the core, shield and spillway, ensures slope stability to prevent failure. And then we can see our seepage analysis, identify and control potential water seepage through the dam by using impermeable material and filter. And then environment impact, that is access to project environmental effect on ecosystem, water quality and wildlife. Include a measure like fish passage or habitat restoration to minimize negative impact. In case successful dam project, integrate engineering and environmental consideration for a safe, sustainable outcome. That's all from our group. Thank you.